All right, so are you ready to dive into some really cool research?
Always.
Okay, good. Because today we're looking at how machine learning is tackling these like really tough challenges
Hmm.
in finance. And you specifically wanted to know more about how blockchain is involved.
Yeah, I'm fascinated by that.
Right. So it's not just a buzzword. We're going deep on this new research data set called FinML-Chain.
Oh, I've heard of that. Yeah.
And it's pretty amazing stuff.
I think what's so cool about FinML-Chain is that it brings together
Yes.
real-world financial data from Ethereum
Okay.
with, get this discussion text, from Discord.
From Discord.
Yeah, Discord.
I'll admit I was skeptical too when I first heard that.
Right.
But the way they're actually using this data is super clever.
It is.
So imagine like trying to predict gas fees on Ethereum.
Oh my.
Like,
Good luck.
total chaos. Trying to guess how long the line at the coffee shop will be.
Yeah.
Like, is it 5 minutes or an hour?
You never know.
But what if you could like tap into the collective wisdom, maybe even like the anxieties of everyone in line?
The vibes.
That's kind of what FinML-Chain is letting researchers do.
It's true.
Right.
It's a fascinating new approach because, traditional financial data,
Yeah.
it has a lot of problems. Right.
So,
Missing information, lack of transparency,
something worse.
outdated numbers.
Yeah.
All of that can really throw off even the most sophisticated prediction models.
Of course.
Blockchain, though,
Yeah.
it offers a solution because it's transparent,
Right.
it's immutable, and there are real-time updates.
Right.
It's just better.
So it's not just about security then.
Well, it is that too.
You're right. It's like this single source of truth, like
Right.
a tamper-proof record that everyone can agree on.
Yes,
Yeah.
exactly.
Okay, so that's where FinML-Chain comes in
It does, yeah.
because it uses blockchain's like immutability
Uh-huh.
to create this record of like
Yeah.
financial transactions, but also this like community sentiment,
Totally.
which is something you just can't get from traditional data sources.
You can't.
Right.
Nope.
So what are the implications of all this? I mean, can we actually use this data
I think so.
to like predict future gas demand on Ethereum to make the whole fee system more proactive?
That's the hope.
I mean, predicting gas fees is incredibly difficult, isn't it?
It's, it's tough. Very complex.
Right. I mean, how do we know it's going to happen on the network?
Right. Well, that's where the power of machine learning comes in.
Okay.
So the researchers behind FinML-Chain
Yeah.
tested a whole variety
Okay.
of machine learning models,
Mm-hmm.
from simpler ones like linear regression to really complex ones,
Oh, wow.
like deep neural networks.
DNNs?
Yeah, or DNNs for short.
All right. Maybe let's not get too technical here.
Okay, sure.
But what do our listeners really need to know about these models?
Well, think of DNNs as like the brainiacs of the machine learning world.
Okay.
They process these huge amounts of data, and they can spot patterns.
Yeah.
That would be impossible for like us humans to see.
Yeah, that makes sense.
So it turns out these DNNs were surprisingly good at predicting gas fees.
Really?
Yeah, much better than the simpler models.
Wow. Okay, so if these DNNs are so smart,
Yeah.
why not just like let them loose on all the financial data we have?
Well, there's a catch.
Uh-oh.
DNNs can be a bit of a black box.
Mm.
They can make really accurate predictions,
Uh-huh.
but sometimes it's hard to know why.
Oh, I see.
Like, why are they making those predictions?
So how can we be sure they're making like sensible predictions?
Yeah, that's a good question.
Especially in the financial world where trust and transparency are so important.
That's where this idea of monotonicity comes in.
Monotonicity.
Yeah.
Okay.
Think of it like this.
All right.
The more you practice a skill, the better you get at it.
Right. Okay.
So that's a monotonic relationship.
Okay.
And we want the model to follow similar patterns.
Oh.
Like, for example, if the number of transactions on the network increases,
Uh-huh.
we'd expect gas fees to go up as well.
Right. Not down.
Yeah.
So we're teaching the model good manners.
Kind of. Yeah.
Like, hey, DNN, you can't just
Hey, this
spit
is
out
funny.
random numbers.
Yeah.
You have to play by the rules of logic.
Play by the rules.
So by adding these monotonicity constraints,
Yeah.
we make the DNN's predictions like
Yes.
more transparent
Yeah.
and understandable. We
Sure.
can see the logic.
Right.
Okay, that makes a lot of sense.
Good.
So it's not just about getting a prediction. It's
Yeah.
about understanding why that prediction was made.
Exactly.
All right, so far, we've got this amazing data set, FinML-Chain,
Yeah, it's really cool.
that combines blockchain data with this like sentiment analysis from Discord.
Right.
And we've got these super powerful DNNs that
Yeah.
are really good at predicting things like gas fees,
Uh-huh.
especially when we add in some of those monotonicity constraints
It helps.
to make sure they're, behaving?
Following the rules.
But there's still this whole sentiment analysis piece we haven't really talked about.
Yeah.
Like, what are we trying to understand by looking at discussions on Discord?
Well, we're trying to answer this, mind-blowing question.
Okay.
Could the mood of the crypto community
Mhm.
actually influence transaction fees on the blockchain?
Wait, you're saying that people's emotions on Discord could actually affect the cost of transactions on the blockchain?
Yeah. It's a wild idea, right?
That's wild. But how do we measure something like mood?
Right.
Or
Sentiment from text. Yeah, good question. Yeah, it is wild, isn't it?
It really is.
Imagine if the whole crypto community, if their fear or excitement
right.
could actually, ripple through the blockchain and, change the cost of doing business there.
Okay, but how do we even, measure
Right. How do you make mood?
Yeah.
Or sentiment from text?
Yeah.
That's a great question.
Right.
That's where natural language processing comes in.
Yeah.
Or NLP.
Oh, yeah.
So the researchers use this special NLP model called
FinBERT.
which is specifically designed for analyzing financial text.
So FinBERT, reads through all those Discord discussions.
Yeah,
Basically tries to figure out if people are feeling bullish or bearish about the market.
Exactly.
Oh, wow.
It's like having this digital emotion detector that's combing through all these conversations, picking up on cues.
Yeah.
Like positive or negative words, emojis, even the way people structure their sentences.
Okay. And then they feed that sentiment data into those machine learning models alongside the blockchain data.
Exactly.
To see if that extra layer of emotional context would make the gas fee predictions even more accurate.
Yeah, that's the idea.
Okay. So drum roll, please.
All right. So this is where things get a little unexpected. While sentiment did have some effect on the accuracy of those predictions, it wasn't as strong as they initially thought.
Really?
Yeah.
That's surprising.
Yeah, it was a bit of a surprise.
Why do you think that is?
Well, there are a few possible explanations.
Yeah.
One is that Discord, while it's popular for crypto discussions, it also has a ton of conversations that aren't directly related to market sentiment.
I see.
You've got people sharing memes, talking about their day organizing meetups.
Yeah.
All sorts of stuff that might be diluting the signal the researchers were looking for.
So it's trying to listen to a radio signal, but there's a bunch of static in the background.
Yeah, good analogy.
Okay.
Another possibility is that the sentiment analysis techniques themselves could be refined.
Okay.
FinBERT is just one model.
Right.
And NLP is a rapidly evolving field. So there might be other models or techniques that could capture those nuances of human emotion in text even better.
So it's not that sentiment is irrelevant?
No, not at all.
It's that we might need better tools to really harness its predictive power.
That's it.
Okay, so that's where the research comes in.
It is, yeah.
Because it's a constant cycle of asking questions, testing those hypotheses.
Testing and refining.
Refining our methods.
Right.
Pushing the boundaries of what we know.
Absolutely.
Okay, I love that.
Good.
Even though those initial findings weren't exactly what they expected.
Right.
It doesn't mean sentiment analysis is
a dead end.
Yeah, a dead end.
No, not at all.
It just means we need to
keep going.
Keep exploring and refining our approach.
Yeah.
But even with these early results, this whole FinML-Chain project just feels like a huge step forward in how we understand how blockchain and machine learning can work together to unlock these insights about financial markets.
It's very exciting. And, the researchers behind FinML-Chain, they aren't stopping at gas fees.
What else are they looking at?
They think this type of analysis could be used for forecasting demand and supply, designing new trading mechanisms, and even helping us understand the underlying forces that drive market volatility.
So it's we're on the verge of cracking the code.
Kind of, of
financial markets.
It feels that way.
But okay, let's take a step back.
Okay.
And remind ourselves of the key takeaways
good idea.
from this deep dive so far.
All right.
So we started with the challenges of traditional financial data.
Right. All those headaches.
Missing data, lack of transparency.
Yeah.
Then blockchain swoops in.
With its superpowers.
With its superpowers of transparency, immutability, and real-time updates.
to offer a potential solution.
Right, exactly.
And that led to the creation of FinML-Chain.
It did.
This incredible new data set.
It's cool.
That combines on-chain data from Ethereum with off-chain sentiment analysis from Discord.
From Discord, I know.
Right.
Crazy.
And then we got those powerful DNNs involved.
Right.
Sprinkled in a little monotonicity to keep them honest.
Transparent.
And boom. We're getting some pretty impressive predictions about gas fees.
It's working.
And who knows, maybe one day we'll be able to predict all sorts of things.
I think so.
In the financial world, like market trends, volatility, even risk.
The future is bright.
It really is.
And remember, the researchers have made FinML-Chain and all their code open source.
That's awesome.
So they're inviting everyone to join them.
I love that.
It's a collaborative effort.
Okay, so here's a question for you.
All right.
And for all our listeners.
Okay.
If we can use machine learning to predict
something as seemingly random as gas fees on Ethereum, what other aspects of the financial system
what else
might we be able to demystify in the future?
It's a great question.
Like, what other unpredictable events could we potentially get a handle on?
So many possibilities. We could maybe predict stock market fluctuations.
Oh, wow.
With more accuracy.
Okay.
Identify fraudulent transactions before they happen.
That would be incredible.
Or even create a more equitable and accessible financial system for everyone.
I mean, that's the dream.
It is a good dream.
Yeah, it really does feel like we're on the edge of something massive.
It does.
The potential of all this research is just mind-boggling.
Absolutely. And it all goes back to, harnessing the power of data.
Yeah.
Especially the unique data that comes from blockchain technology.
You're talking about those DNNs we discussed earlier, right? The ones that can see those patterns and make predictions.
They're powerful.
That would leave even the best financial analysts like...
totally baffled.
What? How?
Exactly. But remember, those DNNs can be a bit of a black box.
Right.
They can give us these really accurate predictions.
Yeah.
But we don't always know why.
Which is why those researchers added that layer of transparency with the monotonicity constraints.
Right.
Basically teaching the DNNs to follow those logical rules.
Yes. And they actually used a really clever approach to do this.
Oh.
It's called the Neural Additive Model, or NAM.
NAM. All right, break that down for me.
Okay, so...
what exactly is a neural additive model?
So imagine you're trying to bake a cake.
Okay.
But you have a recipe with, like, a bunch of steps missing.
Okay.
You might bake something that tastes all right.
Yeah.
But it wouldn't be quite right.
Right.
So the NAM is like filling in those missing steps.
Oh, okay.
It lets us see how each ingredient, or in this case, each variable, contributes to the final prediction.
So instead of just getting a final score,
Yeah.
like the gas fee is going to be X, we can see how different factors like network congestion, transaction volume, even sentiment
Exactly.
are all affecting that prediction.
It's like being able to see under the hood and watch how all the gears are turning.
Okay, that makes sense.
Good.
But didn't the researchers run into some limitations with like how much monotonicity they could add?
They did?
Without sacrificing accuracy?
It's true.
Right.
Yeah, they found that as they added more and more historical data, those time steps, it got harder to keep both the monotonicity and the accuracy.
So it's like this balancing act.
Yeah, a bit of a balancing act.
You want to use enough historical data to make accurate predictions.
Of course.
Then not so much.
That the model loses its transparency.
It's a tough one.
It is, and that's a key takeaway from this research.
Okay.
There's no, like, one-size-fits-all solution.
Right.
It's about finding the right tools and techniques
for each problem.
For the specific problem you're tackling.
And being open to those new ideas.
Yes.
And sources of data.
New data.
Even if they come from, like...
unexpected places.
Discord.
Exactly.
Right.
This research is such a good example of interdisciplinary thinking.
Yeah, I agree.
Bringing together, computer science, finance, even social sciences.
Oh.
To solve these, like, real-world problems.
And who knows what other innovative solutions are out there.
I know.
Just waiting to be discovered.
Yeah, waiting to be discovered.
And as we explore the potential of all of this.
Blockchain and machine learning.
Yeah.
Super exciting stuff.
It's a pretty exciting time.
It is.
This deep dive has been amazing.
I'm glad.
It's definitely opened my eyes.
To the possibilities.
Yeah, to all the possibilities.
It's amazing.
I'm excited to see what happens next.
Me too. This research is just the beginning.
Yeah.
As more and more people start working with all of this, I think we'll see even more incredible breakthroughs in the years to come.
Well, on that note of optimism and excitement about the future.
Good note.
I think it's time to wrap up this deep dive.
All right, sounds good.
If this episode has, sparked your curiosity, I encourage you to check out the FinML-Chain dataset and the research paper yourself.
Good idea.
We've got links to both down in the show notes.
Awesome.
And who knows, maybe you'll be inspired to contribute your own ideas.
That's what we love to see.
To this rapidly evolving field.
Absolutely.
That's what we love to see.
It is.
Until next time, fellow deep divers.
Keep learning.
Keep those minds open.
Stay curious.
Stay curious and never stop exploring.